today class about the molecularity of a chemical reaction. What is the meaning of molecularity? Molecularity means, the definition itself says, the number of reacting species, atoms, ions or molecules taking part in an elementary reaction which must collide simultaneously in order to bring about a chemical reaction is called molecularity of the reaction. Okay, what is the meaning of this? Number of reacting species taking part in an elementary reaction, which must be elementary reaction, which must be molecularity means it must consider molecularity consists of the elementary reactions. Okay, elementary reactions which must collide simultaneously in order to bring about a chemical reaction is known as molecularity of a reaction. So, number of molecules reacting are taking part in a chemical reaction in single step. They must collide in single step reactions are considered, and single step only they can use the product. That is the main mode of the molecularity of a reaction. The reacting molecules undergo an elementary reaction should go they collide simultaneously and gives rise to the product. Mainly the aim of this molecularity is single step reactions. Okay, examples for molecularity of a reaction: decomposition of ammonium nitrite gives rise to N2 plus 2H2O. Unimolecular reactions. Unimolecular reactions. Ammonium nitrite decomposition gives rise to N2 plus 2H2O. So single molecule, here there is only one molecule can use these two products, is known as unimolecular reaction. It is also single step, it only takes single step, so it is unimolecular reaction. Here the number of molecules is 1, so it is a unimolecular reaction. Single step only can use the products. Next, bimolecular reaction. Bimolecular reaction. What is the meaning of bimolecular reaction? Bimolecular reaction, example, 2HI is H2 plus H2. Here the number of reacting molecules are 2 molecules. They collide simultaneously in single step gives us the product. Okay, that is the reason why molecular reaction is 2. Next, trimolecular reaction. Trimolecular reaction is the number of reacting molecules in a chemical reaction is 3. They collide simultaneously and gives us the product. So, example, 2NO plus O2 gives rise to 2NO2. This is trimolecular reaction. 2 plus 1. Okay, 1. This is trimolecular reaction. Trimolecular reactions. Okay, unimolecular reaction, bimolecular reaction, and trimolecular reaction. But here the condition is more than 3 molecules. They undergo collision simultaneously and gives rise to their product. The probability of giving the product is very much lesser. So generally we say the molecularity more than 3 molecules, for giving the product is very less. So molecularity is more than 3 is very rare, and 3 also less possible. 3 molecularity also rare case and less possible in molecularity. So why more than 3 is very rare? Because because the probability of giving the product on collision of the molecules above more than 3 molecules, more than 3 molecules they collide simultaneously and gives rise to the product in single step is a difficult process. The probability of getting the product in single step is lesser one. So more than 3 is a difficult one. So the probability of giving the products is the difficult one. So next, what we are learning is examples, molecularity, different types of examples we have to see. Different types of examples. Next, looking at another example, decomposition of H2O2 decomposition. I do an alkaline medium gives rise to H2O. Okay, 2H2O plus water. 2H2O plus water. 2H2O plus water. For this reaction, they given some data. That is two steps we have given. H2O2 I minus and reaction gives rise to H2O plus Y. H2O2 plus Y gives rise to H2O plus H2O. So after combining these two reactions, after combining these two reactions, you may get this one. So the remaining terms are cancelled each other. Okay, these data are given in the NCERT textbook. And they also mentioned another point. Rate is equal to K into H2O2 concentration and the I minus concentration. Okay, generally given this type of data. What do we understand from this data? Okay, from the above given data, the reaction takes place in two. This is not a single step reaction. It takes two steps. So one and second one is this one. So these two steps together, and addition together, they can give the final product. So this reaction is not a elementary reaction. It is a complex reaction because it takes two steps. Okay, basing on the given data, which are there provided, we can understand it is not a elementary reaction, it is a complex reaction. The first step. Next, here they also mentioned rate is equal to K into H2O2 I minus. The reactant terms, these two terms are present in the first equation. These two terms, rate law, they have given the reactant terms. These two reactant terms are present in the Equation first one. These are the two reactant terms. They are mentioned here. So the reactant terms, they are mentioned here. What we understand from this equation and the rate law. Thus, rate law, which is based on slow step reaction. This is the important one. This is slow step, this is the fast step. How can we say this is a slow step and this is the fast step from the given data? Because the slowest step only determines the rate of the reaction. Slowest step only determines rate of the reaction. Here there are two steps, but they have taken reactant from the equation number 1. So it must be slowest reaction. Slowest step only determines the chemical reaction. Okay, slowest step is the one which can determine the rate of reaction. Okay, or rate law. Okay, there is a reason why the slowest step. In slowest step, the reactant terms they are taken as the in rate law, because these can helps these two terms. The slowest step reactants only taken in the rate law expressions. Okay, it's a general trend. Why we are taking slowest step? Why don't you take fast step reactants? Because slowest step is the most important one in chemical kinetics in a chemical reaction. How can we explain this one? Because first reaction A to B and B to C. Okay, take another example. This is an example. For a reaction goes to A to B, it takes 30 minutes. It takes 30 minutes. Okay, minutes. Okay. From a reaction goes to B to C, it takes 1 hour. 1 hour or 60 minutes. 60 minutes. Okay, 1 hour or 60 minutes. Okay. We say from this data, we can understand that this reaction A to B is slow. Is slow. Oh, sorry. This is fast reaction when compared to this one. This is mainly takes 30 minutes. This takes only 30 minutes. 30 minutes is the lesser time. This is fast when compared to this one. It takes large amount of time than compared to this one, 60 minutes or 1 hour. So this is slow reaction. This is slow. So the rate, how much the products will be given, how much the products are formed. We want to know the factor, which factor governs A to C. We want A must be converted into C. We want to know how to convert A to C. Okay, which depend on which step. Which step is the main cause for formation of the C. So from the given data we can understand that this step is the crucial point. This is only the slowest step. If it is fast, the reaction must be fast. So it is the only factor which can hinder the reaction, which can stop the reaction, or which can lag the reaction. So B to C is the key factor here. So rate is governed. Rate directly proportional to concentration of B. because it takes larger time than compared to this one. It takes larger time. So if it is fast, the reaction automatically A gets converted into B and B can easily converted into C. So the main hindered factor and which can stop the reaction is B to C. So the reaction is the speed of reaction or product formation possibility. The product formation possibility is depend on this one. Depend on this one. So R directly proportional to concentration of V R is equal to K. For this example, we can write like this. Okay, for this example, we can write like this. Okay. In the same way, you can understand that this is the slowest reaction. This is the slowest reaction, slowest step reaction. Then only the slowest step reactants only present in the rate law. The slowest step reactants only present in the rate law. That is the reason why they cannot simply, they are in the NCERT book, they are simply given only these two reactions. They cannot mention which one is slow, which one is fast, because they are already given the rate law. From this point of view, you can understand. So, they are mentioned in rate law. Rate law contains two reactant molecules. Which reaction contains these reactant molecules? So, equation 1 contains these reactant molecules. So, first one is the slowest one. The slowest only governs the slowest one reactant must present in the rate law. So, this is the way you should understand the concept of rate law to the slowest step, which is the important one. Slowest step is the important one for the for writing the rate of reaction. Slowest step is the one. This is the way you can understand this process. Next, what is the difference between order and molecularity of reaction? What is the difference between order and molecularity of a given reaction? Okay. Now we want to discuss the differences between order and molecularity of reaction. This is the important points. These are very important for the competitive as well as intermediate public examinations. What is the meaning of? We know the meaning of order from the previous classes, and we also know molecularity of the reaction from this video. So, order of a reaction is experimental quantity. We know order of a reaction is experimental. It is not a theoretical one. Order of a reaction is experimental quantity. It can be 0 and even fraction. Order can be 0 order is also possible, and 1 by 2 or 3 by 2 these fractions are also possible for order. Order of reaction is 0 and even fraction values are possible. What about the molecularity? Molecularity is a theoretical concept. It is not an experimental concept. It is a theoretical concept. It is a theoretical concept. So, theoretical concept. It's not an experimental concept. Okay, molecularity cannot be 0. Molecularity cannot be 0 and is non-integer. It cannot be 0, it cannot be fraction. It cannot be 0, it cannot be fraction. It only 1, 2, 3 like this. Whole numbers are possible molecularity. Okay, in molecularity 0 not possible, fraction values are not allowed. Fraction values and 0 values are not allowed molecularity regarding. Okay, actually it is a theoretical concept. Next differences between order and molecularity. Order is applicable to elementary as well as complex reactions. art is applicable to elementary reactions as well as complex reactions. Okay, art is applicable to elementary as well as complex reactions. Here, the molecularity is applicable only for elementary reactions. The definition itself says molecularity means the number of reacting molecules taking part in an elementary reaction which must collide simultaneously and gives rise to product. This is the basic idea of the molecularity is applicable for elementary reaction only. It cannot applicable for complex reaction. Whereas art is applicable to elementary as well as complex reactions. Complex reaction means more than one step reactions are complex reactions. Single step reactions are elementary reactions. Okay. Next. For complex reactions, order is given by slowest step. For complex reactions, order is given slowest step. Okay, we saw the example. That is the example we discussed. Previous example, 2H2O2 gives to Y minus alkaline gives rise to H2O plus O2. In this reaction, we know H2O2 I minus and the next step H2O2 I minus. These two steps we know. Okay. From these two steps, H2O minus O2, the rate they given K into H2O2 I minus. Okay, they have given. We know. Okay, from the previous data, we know this one. Okay, from previous data, we know this concept. For complex reaction, R is given by the slowest step. The slowest step, H2O2 I minus gives rise to the product. This is the slowest step. This is the slowest step which are given in the previous example. Okay, slowest step only determines the for complex reaction. R is given by the slowest step. Slowest step, the number of reacting terms present here. This one, the order is 1 and 1. The sum of this one is 1 plus 1 is 2. R is 2. For the reaction, R is 2. Okay. Next, molecularity of the slowest step is taken as the order of overall reaction. Okay, molecularity of the slowest step. This one is the slowest step, H2O2 and I minus. On this example, gives rise to the product. So, molecularity of this is order of the whole reaction. Order of the whole reaction. This is the concept. So, this is the basic idea of molecularity. This is the way you can understand order and molecularity. Okay. Okay. Next class, derivation part. What is the meaning of zero order reactions and what is the meaning of first order and what is the meaning of the pseudo order reactions? Then reactions depend on temperature. These are the concept remaining for the next class.